Okay, maybe Mbak Tisa, you can introduce yourself. So unfortunately, I don't have your CV. It's a quiet, sudden, and then I think you can introduce yourself to the to our students. So you can talk about what your research maybe, or maybe
Yes, yes.
maybe your personal social media.
Sapur, I am right. Okay.
Okay, so let's start. Mbak Tisa, thank you very much for your coming. Mbak Tisa, thank you very much for your coming today. So we are very happy that you can join to this meeting. Okay, so I hope that you can share with us about the new maybe technology. This is not technology, but the algorithm, right? The algorithm that we can maybe learn today. Okay, thank you, Mbak Tisa. Okay, now time is yours. Thank you.
Thank you. How about now? At first, I want to check
Swap.
my.
You need to swap.
Oh, I need to swap. How about this one?
Okay, I think it is okay.
Okay,
Yeah.
thank you. Baik, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Okay, good morning to Pak Putu and of course to all of the students here. I am really glad and enjoy, of course, to present about my core research about machine learning and AI for economic and medicine. My name is Siti Saada, just like Pak Putu said, that both of you can call me Tisa. I joined Intelligent System Research Group, and right now we will discuss first about the introductions, of course, about myself then. And after that, the economic, medicine, machine learning, and AI itself. And after that, of course, I want both of you know about the explanation and correlations between them. And the third step is, of course, I want to see that this machine learning and AI can be implemented to the scope of economic and medicine. Of course, the last thing is the conclusions. And of course, Pak Putu says that both of you have an assignment or maybe a task to make an essay about a question that I will give to you. At first, this is my name and my academic background. I come from S1, I mean bachelor and master degree from Informatics faculty. My office in Kutubaya Utara building, first floor, in the E102 room. If just in case one of you want to discuss about this topic research, do not hesitate to see me in that room. And since 2009, I become lecturer and researcher in this university, and I have a double job around 2013 until 2020. I mean, as a head of data and performance human resource director. Of course, my topic research close enough with the topic right now about data mining around 70%, AI and machine learning around 60 until 80%. And then let's start it with the first very definitions of economic or medicines. Maybe one of you want to answer about this. You can type it in the chat box. Maybe both of you come from the subject of non-technic, usually familiar with the term of economic or medicine. Okay, I will make it clear that economic that comes from words ecos and nomos consists of several aspects in our daily life. So it cannot be hesitated that economic is a social science that concerns with the production, distribution, and consumption of goods and services. Because of that, this focus will relate much with our not only daily life but also about our future or maybe long-term as a consumer and a producer. Because of that, in economic science, we usually have the term about macroeconomic and then about the microeconomics. In this slide, I want both of you know that my implementations will tell much about economic indicator. So at first, I want both of you know about this. And then how about medicine? Of course, medicine from so many several sources say that this is the science that caring for patients, managing the diagnosis, prognosis, to treatment, or maybe to heal about the disease that patients suffer. It comes from Wikipedia or maybe from Oxford Dictionary. It is clearly stated that medicines correlate with our body, and then about our heart health as well. And how about a definition of AI and machine learning? The first thing that usually comes to our mind is AI must be I will say fake intelligence that people product and then embedded it into the system or maybe into the machine. Literally, AI is the theory and development of computer system that able to perform tasks normally, which is require human intelligence, such as our visual and then our speech, and of course our decision maker in order to make some choices. Okay, and then what about machine learning? Machine learning is the use and development of computer systems that are able to adapt. And then the system will learn how to follow the explicit instructions. Because of that, after this slide, you will know about the data training and data testing, because we have to analyze and draw inference from patterns in the data. So AI comes from four aspects, actually. It is like thinking humanly since 1986. That Haugland said the exciting new effort to make computers think, machine with mind in the full and literal sense. Besides these definitions, AI have the enhancements to definitions. The aspect of acting humanly comments in the 90s in order to make it more clear that AI not only about how computer thinks, but how the intelligence, when performed by people, it can be adapted into the computer, we can say it, thinking. And then at the same decade, AI become more acceptable, which is the definition of AI already come up with thinking rationally. And in this term, AI means the study of mental faculties to what? To make it possibly to perceive, reason, and act. Just the same as thinking rationally as human being. And then at last, AI until this now is commonly used for acting rationally, because AI can emulate intelligent behavior, not only to the branch of computer, but also nowadays we already know about robotic or maybe gigantic autonomous vehicle or gigantic robotic for surgery, something like that. And some areas of AI applications, it comes from four aspects that I said before. At first, we will see that AI applications will search some things, and then based on the reasoning, I will start with based on the machine learning mechanisms, it will relate to the visions right now. And of course, the searching's output will become an input for the reasoning, and this output will combine with the searching output to have a planning, which is I quote as a robotic era. And beside that, we also know that AI applications can have extendable for their mechanisms, which is we usually know as knowledge representations. And this is the trigger to have the expert systems. Like nowadays, we usually know expert system for predicting maybe heart attack, and then expert system for predicting the growth of COVID-19, something like that. And the last but not least, nowadays also become booming about natural language processing. That this is also the AI application itself. And how about machine learning? Machine learning as a subset of AI is emerged at 1980s, and until nowadays, it become the parents of deep learning that usually we use it to solve the complex problem. And according to the definition of machine, usually we familiar with computer or maybe computer program, but learning said to improving performance on a given task based on experience or example. So how if we combine the machine learning definition? So the definition of machine learning is to concern about computer programs that automatically improve their performance through experience. The experience I will say it twice. I mean, this repetition is important because, as I said before, it will correlate with the data training and data testing, which is we want to make the pattern of our model. The taxonomy of machine learning actually consists of three phases, but today I just want to share about the supervised learning. In here, supervised learning is a mechanism that we usually want to make some decisions about the level of the data. For instance, here, the input raw data at first didn't have any knowledge about their classification or maybe about their prediction, or maybe there is no information, just as it is. After that, we use the algorithm of machine learning, and the machines will try to rebuild time over time about the desired output. But in the meantime, the system build their system, we will have data training or maybe training data set. After that, the processing of this system will have several output for maybe the classification from the data raw, or maybe for the prediction, something like that. So supervised learning is the mechanisms that will include the target values. I mean here, we will try to learn a function that correctly maps the target values from the other features. And then we can make it as the output as we want. There are two flavors of it. This is actually the core theme that I will share after this. The first one is classifications, which is, this is really concerned about the label. And the second one is regression. This term more concerned about the value from the output. Okay. It just the emphasis of the machine learning definitions. And then before we go to the implementations of the research in this machine learning or maybe AI, I want you to know first about how to calculate the performance. Why? Because at the first time I said about machine learning, I already clearly state that there is performance that we want to improve automatically, kind of automatic, because the system will learn by themselves. The prediction type to evaluate their performance, if it classify at regressions, at first usually we use MSE or mean square error, or MAE, mean absolute error. Besides that, the classification have different measurement of performance. At first, usually they use accuracy, F1 measure, precision, and recall. For regression, evaluation performance, we can see here to measure the error first. As the equation, we want to know about the difference from the data predictions. We will calculate about the data predictions between the data actual, and this is also will happen into the others regression variant. Besides that, evaluation performance for classification, we use confusion matrix. As I said before, we have predicted class, classification, and then actual class, predicted classification, which means accuracy is the ratio of correctly classified data compared to all data. So this is the equation when we want to measure about the accuracy. Okay, and this is the explanation of true positive rate, which usually we call as recall or sensitivity. If this term, we want to know about the ratio of correctly classified data as positive compared to all existing positive data. In other words, it can be said that we just want to know how much positive data was recognized. And then how about the true negative rate? We usually call that specificity. This is the ratio of the correctly classified data as negative compared to all existing negative data. And in this term, we want to know how much negative data was recognized. Okay, I think this enough. This is the last performance matrix tools, precision. It is usually really popular in case we want to classify it in machine learning. In this term, we just want to measure about the positive predictions were correct. Okay, and this one is F1 measure, as I said at the first classification slide. Okay, our performance evaluation. I mean. Okay, I will just skip it. I think that all of you already know about it. So how about a good classifier? One is it? In this term, I just want you to know again, or maybe to become more familiar about the split of your data sets. It will divide it into three data: at first train data, validation data, and then test data. These portions, of course, relate into the hyperparameter observations. By evaluating them, we will have the best model that we will have then. Okay, this is the train data used to train model. Validation data is to attune the best parameter, or in other case, to check the model performance. And the last is about data test. Is usually have to be used to. So we have to be used to in evaluating the test set at the very end. Okay, I think we just move in. I mean move on, yeah, into the implementation on research and publication. Okay, here we are right now as the informatic bachelor students here. I mean, of course, both of us already familiar with the AI or maybe machine learning. And in this term, I will show you about the first thesis of mine about prediction system of economic crisis in Indonesia using time series analysis and optimized by genetic algorithm. As the very definition of economic that comes from several aspects, here I use 4 indicators with several data that come from economic science. At first, like GDP, which is gross domestic product, as the main economic characteristic in Indonesia, because it gives a demonstration of economic activity, I have to measure about the fluctuations of GDP in order to make sure the financial stability of Indonesia at that time. At the second, I will use the inflation indicator just to measure about the domestic currency to foreign currency, because once inflation happen, of course, it will trigger to the economic crisis in Indonesia, and it will have huge impact because it will make people life become maybe poorer or maybe lose their job and finally maybe make a better worse of bankruptcy. And the third indicator is call it oil, maybe for export or maybe for import term. Indonesia as one of the biggest country which have natural resources, of course, oil become one of the biggest factor to influence about economic crisis. And after that, Indonesia with a huge, really huge population, it will have an impact about their economics just in case the populations have doubled than this time. Okay, this is dataset samplings that already have from the IMF, okay, International Monetary Fund. And then this is the indicator that I said before from 1997 until 2005. This is the sample data. And then I will pre-process it in order to have this similar minimum and maximum range. And this is what I want to measure at last. I mean, I want to make it combine. How about GDP and inflation when it have to predict together? Because one statement from the economic expert said the time that economic crisis happened when the GDP is suddenly dropped, but at the same time the inflations become really huge or maybe at the peak seasons. So based on this hypothesis, I want to know about how the system in machine learning and AI can have the system prediction. Here, I will start, and then this is in the training phase. Actually, the algorithm of genetic GA already been embedded. At first, the population of initiations from the data already been prepared to evaluate the individual then from the data training. And then we will select the parent and the output will become the recombinations that produce the best child. And then by using the mutation scheme, we will have the survival selection from the populations. Just in case we will didn't have the best results, we just have the other iterations until the system has been terminated. Okay, this is for instance, already have the best coefficient for model dynamic, and then we will have the evaluations performance measurement in the testing puzzle, and the data test will insert in this time, and then the result is the function optimal prediction get the best prediction. After that, of course, we will measure with accuracy how much the MAPE fit the data actual during the prediction process. Okay, this is the result of the system. We can see it that the system able to fit the data actual. In the 1997, both of us know that Indonesia suffered economic crisis around 1 year, but the impact have already been felt until this time. Okay, and then this is for the long term. I mean for predict population and oil. The range really have a huge gap. So the result we can see even the pattern already follow about the pattern, but this population predictions have different fitting from the data actual. I mean, this is the use overfitting has been happened. Okay, and this is my AI and ML for economics research journey since 2016. Pardon, this is still in the Bahasa because the journal in Bahasa. And I just want to talk you two of them. At first, the one that I already presented at the Thailand at 2017 about fuzzy inference system in classification result prediction of energy prices in Indonesia. And then I will tell you also about the crude oil price forecasting using long short-term memory. Another publication of mine, you can read it by yourself by this link of conferences or journal. Okay, at first, this is the fuzzy inference system in classification result predicted energy prices in Indonesia. This, we will see the different scheme from the first one. I mean, we already use the fuzzy as the algorithm here. As we can see here, as the start, we have to adjust fish first. And then after the fish have their output, the data testing can be inserted here. Meanwhile, the data actual of, we can see the data history of energy production from oil or maybe from the GDP can be inserted by that time. And we will, of course, measure the accuracy until we get the best one done. Okay. And this is the data sets. I already provide the sample of data set also here from the 1969. We can see the production of oil and consumption of oil in the million of ton, and we will measure about the differences. And we can categorize it as a type of energy. I mean, we already know that Indonesia is a big one that have renewable resources. We still have to be prepared about the crisis of them. Okay, so this is how the algorithm process the data. The fuzzy will have a CRIPS input first. CRIPS mean the data actual, and fuzzy mean as the gray area as a classifier unit. And then by the rule base, it will become the inference unit, and it will output the classification unit. After that, we will have the data classifications in our machine. This is the result of classification first. For instance, I just take for the fuzzy membership of oil. This is the equations, and we can see it about the membership function of them. Okay, after that, we also want to know about the classification of resource energy. There are safe, there are worn, and there are prices. I mean, we want to measure about this range and then combine both of them. After that, we will use the rule like this. If production is little and GDP is little also, then the phase of crisis energy is become worn. But the rule number 2, if production is little and GDP is moderate, then the energy crisis become crisis. So after the system build the fuzzification rule, and then we will have the output like this. We have the class safe from 1969 until the 2002. But from 2003 until 2012, we can classify it at crisis phase. Yeah. So this one, what I mean, ML or AI can become a problem solver for decision making, or maybe for become information knowledge in economic skill. And then the second research of mine is about crude oil price forecasting using LSTM or long short-term memory. Actually, it's already deep learning mechanism. As we can see that crude oil is an important energy resource. But during the period 1980 to 2006, Indonesia has the largest total of energy consumption. Despite the renewable energy being the focus industrial and technological area at present, and the costs involved are still quite high. Because of that, this become the limitation of the availability technology that support renewable energy. And moreover, machine and equipment that use renewable energy are still on a small scale, thus limiting the use of renewable energy, and the efficiency of the use of it is still lacking. Okay, because it's still not capable of transportation, storage, and technology to achieve it. And until now, crude oil still has the biggest share of the world's main energy source consumption. Because of that, the prediction of crude oil prices is quite important because it can help make better economic budgeting and planning. Okay, so by that introductions, LSTM become the term of algorithm that we choose in order to mitigate the overfitting or maybe the underfitting during the crisis, during the prediction time, I mean. Okay, this is LSTM as the child of the RNN, which is recurrent of neural network. And it's actually designed from 1997 from Jordan Smith-Huber. And this want to improve the RNN performance, which have difficulty dealing with vanishing gradient. Which means there is the forget and the remember term in here. And this is the calculations how to alpha make have long short-term memory here in order to mitigate about the error of the RNN. Okay, and here it is about the term of the flowchart from the system. Actually, this is the same classifying data split. At first, data will be normalized using pre-processing technique, and then the train and testing data. The train data will have a model, a base model, I mean, and then it will test it to the prediction result, and of course, it will evaluate. It will be evaluated, and the result of it will be the best one that we want to analyze. Here it is about the result. Actually, this is what I said about the hyperparameter before. Here. LSTM have the look back and then the batch size, and we can adjust it one by one, and then we analyze how about the results and the iterations in the deep learning set as a FO. And the results said about RMSA in train and then in testing phases. After that, we will measure it in May also. Okay. From the fluctuations of the data actual and data predictions, at first we can see that it is clear enough, can be classified or maybe best in fitting to the data actual, the data prediction. But if we change the data, I mean, during the data from another range of year, they have different result from the data actual according to the data prediction. Here we can see the blue line as a data actual cannot be fitting well by the data prediction. Or in other words, it can be said it still have an error even if the system still have a good one of result in this year. Okay. So so many of journal, best journal maybe when we have to publish in that journal, I mean, we have to have state of the art here. Our result will combine with the others of previous publications. So it can be stated that even our result give more better than before, but more layers do not necessarily give better result. So this one I want to say is when you have a model, because this is the deep learning approach, of course, they have layers here. And we want to measure the combination of the layer and the hyperparameter as well. And after that, we want to measure about the accuracy using the RMSE and MAE. And the result said that our result have the limitations about the user of layer. Okay, because of that, yearly stopping method to help determine the number of epoch in the model has a positive impact in our prediction result compared to manually selected number of epoch. Okay, I think that's all for the economics. For the economic cases, let's continue to the AI and ML to the medicine. I will declare two of my publications. At first, about blood glucose predictions using convolutional LSTM, and then the other one is early detection of cervical cancer using chart, or usually we classified it as classification integration rate. At first, early detection of cervical cancer using chart. Here, we have to know about the causes of cervical cancer first. I mean, women that have cervical cancer usually have first pregnancy at the age under 17, the use of nicotine, the extensive usage of feminine hygiene, the number of children who are born, and then the family history. This is the huge aspect that usually females suffer from cervical cancer. And according to the algorithm chart is the method to do using the regression tree, which is the decision tree here. Okay, the tree, as the name itself, usually have the root, and then there are several branches that come from the decisions in their choices. Okay, I will just make it fast. And this is the accuracy performed by cross validations, which is there are precision, recall, and F1 score. And this is the three first. We want to detections about the female who have negative or maybe not yet, and then maybe positive from the blooding from their cervical. And if there is blooding beyond or maybe behind their menstruations, they have to see the doctor to test about the cervical cancer. If in otherwise, if there is no other indications, they'll just have to check about their ancestor, maybe their history family about the cancer cervical. In the other hand, if there is no history family who has cancer, they have to answer about the other question again, just to make sure if there is cancer or not in their body, in their cervical, I mean. And the system have the accuracy about 99%, which is there is still incorrectly classified instance. There are several instances that will measure it false, but in other words, it can be said that it's still best enough in making early detection of cervical cancer. And according to the precision, we can see here, and also the recall, the same measure also stated as a representative of accuracy. Okay, and after that, this is the second title of ML and NI for medicine. Actually, it is been published recently on August 2021 with the title Blood Glucose Prediction Using Convolutional Long Short-Term Memory Algorithm. In here, usually we will have a restricted data from data healthcare. I mean, this is really confidential, but several sources make it open. Both of you can download from here, this resource, Center for Health Research. And then, of course, there is record ID, and then about patient ID and the characteristic of data set. There is also device when they came to the hospital, and then this is the value of the blood performance from the patient. And here it is the system that will measure diabetes mellitus. Why it is still happening or still booming until this time? Because this is the leading cause death in the world. Maybe beside cancer or maybe beside heart attack. And there are so many effective approach can be taken to prevent diabetes actually. But unfortunately, maybe we lost focus about it, or maybe we just ignore it. So it will. So the system, the system offer about the prevalence, complications, and any other complications from the blood glucose. Okay, this is the convolutional LSTM word. This is actually the family of LSTM itself. So I make it the structure. First, you know LSTM in the economic, and then you know the other convolutional LSTM in the medicine. Cases. First, we start the data to load the CGM. CGM, the characteristic glucose of the patient. And then choosing random patient, we set the model count here. And then until the model count less than 5, if the output is still the lowest RMSE, we will reduce about the data, or maybe we have to adjust another hyperparameter. In other words, if we have the yes result, we have construct the training and then construct the model LSTM, initialize and start training. And after that, of course, we want to store the temporary model until we get it done. Until, we get the best parameter here. And we will have, I think this is N, not start, right? Until the system make it the result better. So this is the different LSTM from the one before. There is convolution here. At the LSTM slide, you just know what forget input and output. Here you already have the enhancement of them. There is plus here, which means convolution itself. And the equation also have the enhancement here about the convolution. And the result about the prediction with the ratio of cross-validation data 70 between 30, data training, in data testing. The patient here, we just perform for patient, and we can see that this result is good because the data can fitting the data prediction, can fitting data actual. Data actual in blue line, legend. Okay, so how about the accuracy in this system? The MSE said that the train and test still can be accepted. It can be accepted either in the money and between train and testing phases, because actually it's already dropped from the RMSE. It means that it is a good indicator from the system. Okay, the finding this study indicate that more stable compare of ratio 80 between 20, and this is also the result. Okay, so it can be stated clearly that the system succeed in predicting blood glucose to prevent early about the diabetes mellitus. Okay, and this is actually about the you can call it platform or maybe
Cheat sheet.
cheat sheet. Tadi I want to say cheat sheet, but is it okay for the students? Cheat sheet. Okay, this is very scikit-learn. You can use it from regression. You can make it clear, which is classification, and then how about regression and the clustering, and then the dimension reduction. You can get it from the selective course, which called data mining or maybe process mining. A lecture with Miss Ima or maybe another lecturer. Okay, so this is the conclusion of this courses. Actually, I want to highlight about the future of AI or ML according to the economic or medicine. At first, we already know that AI become the new electricity, and because of that, the computing is becoming free. Both of you know that there are so many cloud that we can achieve from anywhere or everywhere. And because of that, the impact data is becoming the new oil. And so machine learning is become the new combustion engine. From the data, it can be seen that 2 years later, the use of AI revenue by the regions, according to the world market data, there are so many countries around the world will use AI or ML in their activity life or in their industries application. So because of that, it is according to my questions for you, for both of you. I want both of you make an essay about the challenging part of doing some research about ML, about machine learning and NI, I mean, for economic and medicine in the future. And you can answer it using SWOT analysis. I mean, you can explain from the strength aspect, weakness, and how about opportunities and the threat of them, maybe in the 5 or maybe the 10 or maybe 110 years later. Okay. Thank you. I think if both of you have some questions, please let me know. And if both of you want to make some collaboration or maybe public services, just email me. And I think that's all.
Okay, thank you. Thank you. Thank you, Ms. Tisa, for your presentation. I think that's a good information about the AI and machine learning and how they can go to the problem of economics, or this is the financial, right? The financial computings or medicine. Okay. 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 I need one questions for student. So I open one questions. If there are any questions.
Which one from Rifki? May I read it by myself?
Okay, so this one.
Okay, I have a question from Rifki. Yes, which one is harder? Collect the data for the research or creating the formula or implementation to solve the problem? Pak Putu, maybe. Feel me also.
Mbak Tisa, I think your signal is bad.
This is really a big, yes. Oh, how about this one? Check.
Okay, I think it's okay.
Oh, okay. I just stopped the video. How about this one? It is okay?
Okay, it's okay.
Okay, I'll try to answer it first. Which one is harder? Okay, actually, as I become the researcher since 2009, getting the data is become more harder than having the Formula One. Pak Putu maybe can edit the some information from my answer.
Yes, sure. I think the data is difficult, right? So since
Yes.
that we need, we create the model from data. So the data is the problem.
Yes. Okay. Good, Rifki. Sorry, am I say it right?
Yeah,
Yes,
yeah,
Rifki Aulia
yeah,
Rahman.
Aulia. Okay, so any other questions? Any other questions? Any other questions? So Mbak Tisa, so I
Yes.
have one question. So where we decided use the arbitrary machine learning or anything compared to using the deep learning. So when we decided to use those algorithms.
Okay, that's a tough one question also. The answer is when you have the more complex from your data and then your cases, of course, the AI or the machine learning cannot be clear enough or cannot be tough enough to answering our problem. Because of that, deep learning come as a tough one, as a maybe a clear one for your problem. But in my experience, there is still maybe kind of screw or maybe kind of different analysis from that answer because I have a complex problem, but deep learning failed to have a good result. In other cases, AI come as the best algorithm which revealed to that issue. So if I want to conclude about my answer, at first, of course, we have to use deep learning for the complex one first. After that, if it doesn't work, you can choose AI or maybe machine learning because maybe the complex ones just stated clearly into the simply one algorithm in AI. And like that, Pak Putu.
Okay, thank you. Thank you, Mbak Tisa, for your answer. Okay, so I think that's all for today. So I need to give appreciations for Mbak Tisa. Just a little bit
Yeah.
appreciation. This is not in dollar, but okay.
Wow.
Okay, so
Wow.
it's
How
just
about Europe? How about Europe, Pak Putu, or maybe pound sterling?
okay, we will send you as soon as possible.
Thank
Okay,
you, thank
so
you.
yeah, so give you this appreciation. Thank you very much again, Mbak Tisa. Hope that you can have your doctor degree as soon as possible.
I mean,
Maybe this
thank
year.
you. Yeah, thank you.
Okay, so this year you have a PhD study. Okay,
Yes,
so yeah, I hope that you can share again maybe next time with us. Okay,
of course, of course. Thank you
okay,
for your
okay.
invitation.
So I think student, you can open your cam now. Okay, okay. Wait a minute. Okay, so I need to please give applause again to Mbak Siti Saadah Tisa to her performance today. Okay, so please give up your good pose. I need to yeah, take a photo. Okay, so in 3, okay, 1, 2, 3. Okay, so thank you again. And I hope
Thank
that we
you,
can
President.
meet again in another occasion or another meeting. So also the student, my student, thank you very much for your participation today. So I hope that you can join next week. Okay, next week we have another speakers. Okay, but unknown speakers. Actually, I couldn't. Okay, announce. Yeah, we can surprise. Okay, surprise maybe on Friday. Friday surprise. Okay, I guess. Okay, so I think thank you very much for today. Thank you. Bye bye.
Thank
Goodbye.
you, bye-bye. Tell student have a nice weekend. Assalamualaikum.